Hello, thank you very much for joining our session on getting started with AsyncAPI. My name is Dale, and I'm joined here by my colleague Nick, and we're engineers from IBM with a background and an interest in Kafka. So although AsyncAPI is protocol agnostic, we're really going to be looking at this through the lens of Kafka developers, Kafka users, although a lot of what we say is more generally applicable. So there's a few things we want to go through today. Firstly, we're going to start by telling a bit of a story. We want to set the scene. We want to explain what sort of problem is AsyncAPI here to solve, some of the problems it can help with. Then Nick's going to go through the spec in a bit of detail, take you through what the spec looks like and how you can write your own document. And then finally, we'll finish up with a few demos. We'll show you what kinds of tools you can use that understand the spec and some of the things you can use an AsyncAPI document for. So that's the plan. Let's get started. Like I say, we'll get started with a bit of a story to talk about why you might want to consider using AsyncAPI. So imagine I'm a developer, right? And my manager will come to me with this idea for a new project. And in fact, my manager never talks about projects. They talk about opportunities, which always makes me nervous. But imagine they come to me with this project, this opportunity that's maybe something about getting data from some sort of Acme corporate backend system, getting events out of that system, doing something with them, processing them, and pushing out some notifications somewhere. So I'm a Kafka guy, so I'm going to be looking at that and thinking that Kafka is probably where I want to get started. And I might want to go looking to see, something like Kafka Connect. If you're not used to Kafka Connect, it's a framework, a standard way of getting data in and out of Kafka from other external systems. So I would probably look at that and say, find a connector, work out how to configure it, get the events from that external system into Kafka, do some processing, and then push out those notifications. So I'll probably start with that connect piece. How am I going to get the data out of my backend system and into Kafka? And if you've used Kafka Connect before, it can be a bit fiddly, particularly if you're working with a connector that maybe isn't very well documented or has a lot of config, has a lot of options. I've easily burnt a lot of time doing this bit before. So maybe I spend a while fighting with that and I eventually get it done. And I'm chatting to Nick later and sort of saying that, I've spent the last few days fighting with getting this connector working and getting the right credentials and the right config. And I finally managed to get a Kafka topic with events from this Acme corporate backend system. And he likes to spoil my day. So maybe that's the point where he breaks the news to me that there's already a topic on our Kafka cluster with events coming off this system that I just never knew about. So I've kind of wasted my last couple of days. So that I'm going to be really sad at that point, right? But that's fine. I'm a professional. I'll get back onto it. So maybe that first part of the project I didn't need. I'm just going to focus on processing those events. And that's, again, where things can be tricky because I know I need to write some code that's going to do something with the events that come up. But if I wasn't involved in setting up that topic and I don't know who did it, I'm probably not going to know the shape of that data. Is it, because it's just bytes on a topic in Kafka land. So do I need a schema? Is it a string? Even if I can tell it looks like a string and looks like JSON data is just keys and values. What do those keys mean? What does each field in the data mean? How am I supposed to write my app without some deeper understanding of the semantic meaning of that data? So again, I'm back to being stuck again. So the point of this story is these are the kind of problems that AsyncAPI is here to solve. How do I know what clusters, what topics are available in my enterprise? Even when I find the topic I want to use, how am I going to understand the data that's on them? And once I've found the topic and I have an idea of what data is there, what is going to be available to me to help me get going with it as quickly and efficiently as possible? And obviously our answer to all of these questions is, or at least what we're going to suggest to you today, is that AsyncAPI can help. And with that, I'm going to hand over to Nick to introduce you to the spec.
Wonderful, thanks, Dale. So as Dale mentioned, we have a Kafka background. AsyncAPI has become on our radar for ways to try to articulate and describe these available Kafka event sources. But AsyncAPI in itself is a specification typically expressed via YAML or JSON. And for those of you familiar with OpenAPI, we'll start to instantly spot similarities. This is a document format designed to be both human and machine readable that will help answer the questions that Dale was mentioning earlier. So what I'm going to do is just open up a Studio instance and talk you through an example async API spec. So an async API document has a series of top level fields, each of which have significance within what you're trying to describe. So ultimately, the purpose of the document I'm displaying today is to provide documentation of a series of Kafka topics available with in a scenario around changing the stock levels within a warehouse. There's a Kafka broker that has messages available on this topic. And the purpose of writing the document is to allow other people within your organization, other people within your business, to be able to consume and read this document, both programmatically and from a human semantic purpose. So the first thing we're going to look at is the async API tag. That simply specifies the particular version of the async API document that you're writing. In this case, we are using the latest version of the spec as of today, which is 2.3.0. We have an ID that is simply a unique identifier to help identify the document we're writing. In the info section, this is where we can start to provide sections of human readable pieces of the specification, which we can see is rendered on the right-hand side in Studio, but the idea being that what we have here are a series of descriptional pieces of information. We have a title, we have a version of this particular API that we're describing. We have a description, and you'll notice support here for Markdown. So this is rich text, as we can see on the right, being rendered with the images, etc., that provides a description of the particular topics and cluster and purpose of the application that's being described here. We have terms of service. Perhaps if this document is going to be shared externally, if you're describing an external API, you might need to provide a more formal description of how the agreements when you start using the API. Some contact information and then license. In this case, we're saying this is an Apache licensed API, and the code itself is also licensed under that. More metadata around the tag section allows you to describe different tags that maybe you would use to correlate and to associate groups of APIs, perhaps. And then if you wanted to provide much further information for developers, you can actually provide links in the external docs section with a URL to some remote Markdown GitHub pages, wherever you prefer to document. So the info tags and the external docs ultimately result in a human readable way to describe the purpose of the application described with this API. But then we get into more of the operational side. So we have servers and we have channels. So in the servers, the idea behind here is that you are describing the endpoints that can be used to consume or to publish messages into the application described by this async API. So as Dale mentioned earlier, we're Kafka based. So for us, the kinds of brokers or message backbones we're describing as part of the asynchronous event architecture is with Kafka. Async API is protocol agnostic. There are supports inside for multiple types of protocols. But in this case, we're talking about Kafka. So we are describing in this scenario 3 bootstrap servers. So we've got a 3 broker cluster, my broker 0, my broker 1, my broker 2. We are using the Kafka secure protocol to identify the fact that the brokers are secured with an SSL connection. We're using protocol version to make it clear the Kafka protocol version that the brokers are supporting. We've got a description. So in this particular case, we're stating we've got a broker that's running in the central warehouse, one in the east warehouse, one in the west warehouse, all contributing to the same Kafka cluster. And we have the ability to define the security. Now, the way that Async API allows you to define security is via a security section in the servers. And that implicitly is correlated down into the component section, which I will explain later. But the purpose of here is we're saying that each of the brokers are using this defined security component. And in the component section is where we will actually detail the explicit Kafka binding and Kafka security specifics. So having described the servers, this now tells me where I need to connect my Kafka application to be able to interact with the application we are describing in this document. And the really important thing now is to look at the channels. And channels maps to a Kafka topic. And the purpose of the channels are explaining the inputs and outputs of the application. So from a purely programmatic perspective, a channel describes where, in Kafka terms, you would publish or consume messages from. But the additional value that AsyncAPI adds for this is the ability to add the human readable descriptions. So it's not just about knowing where you can subscribe and publish messages to, but also understanding the purpose of the channel, how the channel is being used by this application. So that you can not only know that if you want to interact, you can send a message, but a description as to why you might send that message, what the result might be, giving you more metadata to understand the application. Given that, as Dale mentioned in the story earlier, part of this document is allowing people to discover and save the time that they would have spent building their own application, building their own connections into Kafka. So inherently, it's incredibly useful to be able to say, this is the purpose of the topics that exist. So as I said, channels conceptually maps to topics in Kafka. And there are two key parts of an AsyncAPI document when describing a channel. You have the subscribe operation and you have a publish operation. And a subscribe operation means I am telling, by writing subscribe here, I am stating that anybody who writes a Kafka application that is interacting with these topics needs to subscribe to be able to get information from here, and needs to then publish to send messages into the application itself. So the operation we've described, operation ID, very similar to OpenID, OpenAPI is a way of identifying this particular operation. And we're saying ultimately that in order to consume the central stock event, then you're needing to subscribe to this topic. And from a bindings perspective, we have specific protocols in AsyncAPI. In particular, there is a Kafka binding that says if you're wishing to use this operation, you need to use a client ID that maps this pattern, and your group ID needs to map this pattern. You might have in your backend a Kafka ACL or some level of authorization that means that actually only specific patterns are acceptable. After the bindings on an operation, we then talk about the message. So the message is where you can give the human readable and machine readable descriptions of the messages that are actually going to be stored on that topic. Or if you're publishing the messages into the topic, the structure that needs to be conformed to. So the human readable sides, we have things like name, title, summary, description. Description contains markdown, for example. And then we have the very interesting schema format. So anyone who's familiar with Kafka will understand that typically Kafka talks about Avro messages. But if you were putting, say, a JSON message onto your topic, then you might want to use a slightly more simpler, the AsyncAPI schema format as a way to describe the schema that's going to be included. If you were actually ensuring you were using Avro on your Kafka topics, then you might want to actually describe the Avro schema, because then a computer or program would be able to read and consume the schema as is. The AsyncAPI schema format takes it's a JSON, a YAML object around the payload, and we talk about things like required type. So we've got a payload that's an object. We have a series of required properties on there, and in those properties, we're describing there's a catalog ID, there's a default value on the type, We've got an integer count. These map essentially to JSON fields in a JSON object, or if you were using an Avro schema, obviously they would map to the Avro fields as serialized. We also have in the document specific Kafka information around the headers. So you can describe the headers that might be included in the Kafka messages. Scrolling down, you have the example payload. So one valuable thing around making this more consumable for human readable, for human users, is that when you're actually exploring the document, you might want to understand what the payloads would look like. So although the schema says that there's a date, the schema says there's an integer, these might have specific semantics. It might be that actually that integer is representing a range of values, or you might have the string is actually a postcode, for example. So with the payload examples, you can start to display more valuable examples of the schema, so that somebody who is consuming the document is able to infer a bit more semantics over the meanings and the values that would be provided inside the messages on that topic. You don't have to, however, define these things in line. So you can see that we have $refs, much the same as in OpenAPI. The $ref is used to reference values from the components section of your document. The advantage of using $ref is it means that it encourages reusability. So by referencing inside the components, you can use this item multiple times within the document. Additionally, we can see that as we scroll down to another operation, you can also provide a ref that points externally. So in this example here, we are saying that there's a Avro schema. We're using content type to state that we are using the Kafka messages will be in binary. So our application octet stream is a content type that we can use to state a binary encoding rather than a JSON encoding of the Avro messages. And the $ref here points to an external GitHub URL and means that the payload in itself doesn't need to be stored in the document. You could store and manage that within separate repositories, GitHub, etc. And then finally, in the components section, this is where we have our reusable items. So for example, in this document, we're describing reusable bindings in operations. So the ability to have a reusable client ID, group ID structure. We are talking about security schemes. So previously in the document, we saw that there was a mention on the servers of a specific Kafka security setting. The security schemes, the supported types have been updated as the spec has evolved, and now support additional Kafka security schemes such as explicitly Scram SHA 512, the ability to actually then provide more documentation to the user to say that not only have you got a secure Kafka system, the authentication is based around a particular type, be it Scram, be it mutual TLS, etc. And then finally, we have used a reusable messages section inside the components. So if you had topics that actually did share similar events, maybe there was a level of enrichment, etc., that meant that you were using multiple topics in your application to combine and provide a single derived stream at the end. They might all share the same message structure, at which point using the messages in the components section gives you a much more reusable section as well. And again, all of the fields that we've seen in the embedded message can be used in the spec in the component section as well. So ultimately, whilst this document is rather verbose in the way that we've written it, it's to demonstrate the different manners in which you can structure your document. But the principle ultimately being is that by writing this document, we've been able to answer the questions that Dale was proposing earlier. So just to summarize, the main chunks of the document we looked at are the top level info, servers, and channels and components. They're the key top level attributes of the async API that are important whilst describing Kafka topics. And we've taken a deeper dive into the individual structures of those documented fields as well. And I'll now hand back over to Dale.
Awesome. So that's what an async API document looks like. And in terms of why you might want to do that, that's what we sort of talked about at the start. And to me, the strongest motivation for that is just that having human readable documentation available to developers, so they know what's available, they can discover the topics that are available to them, they can get started. All the information they might need to write their application is in that one document. But that's not all you can do with them, because as this standard, as an open standard that's growing in popularity, there's an increasing number of tools and systems that can do things with an async API document, that understand how to interpret them and parse them. So we wanted to finish off just by quickly showing you a few demos of just a few of the kinds of things you can do if you write one of these documents. So we'll start with code generation. So imagine you've described, you've designed your application, you've written out the spec, you've written out a document that describes what topics it will use and what the messages will look like. The next bit might be to start writing code, but you don't have to. There's a generator that comes from the Async API community called AG, and it supports a huge range of plugins. So what you can see here, I give it the location of my Async API spec, and it could be a local file, doesn't have to be online. And then which generator I want to use. I'm going to use Java here because I tend to write a lot of Java, but there are other generators for other programming languages too. There's a few parameters I need to give it. What folder do I want it to do the generation in? So I've picked source. What package name do I want it to give to the Java classes it generates? So I'm going to go with eda.demo. And then that's it. I hit enter. The generator will churn away. And as you can see on the left-hand side there, I've got a load of new files that have appeared. This is a complete, working, ready to go application. There's no real business logic in there, but all the boilerplate scaffolding I need for a Java application that can subscribe and produce messages, consume and produce Kafka messages, is ready to go. And it comes with this one. This one comes with a sort of Maven setup. So I can literally, without having to do anything to the app, it's ready to compile with a single command. So now I'm ready to go from just having my document that describes the application I wanted to build. I now have all the scaffolding in place, and I can just start adding in my business logic. So async API documents can make you really efficient as developers. Another way that we like to use them is, again, if you've described in an async API document the application you're intending to build, and you get your teams to divide up and start working on, maybe you've got one squad that's working on consuming the messages from that topic, another squad that's going to be producing those messages. A mocking system like Microx, another open source tool that has support for async API, is a nice way of helping your developers be productive, because that squad that's going to start consuming the messages and processing them, they don't have to wait for that Kafka cluster to really exist or that topic to really exist if they've got a description in async API. So you can go to Microx, upload this async API doc, as you can see here, and under the covers, what this is going to do is set up a Kafka cluster, set up a topic, and it's going to start generating events using the description in the async API document of what those events should look like. There's enough information in there for them to start generating mock synthetic events. I mean, the actual contents of the messages will sort of be gibberish, but they'll have the right shape, the right data types. And it's enough maybe for your developers to start writing their consuming app again. And I'll show you here with just a console consumer, just so you can sort of see. Immediately, I start seeing messages start to appear every few seconds, and I can choose in Microx how frequently I want the messages to get generated. So again, going to the time of describing the message, describing your intended Kafka topics in an async API document can make your developers really efficient, because they can start developing their applications before the Kafka cluster and the topic and the messages even really exist. Finally, one last example, again, looking at how we can make developers efficient and productive as quickly as possible. Rapid prototyping. If you haven't seen this tool before, I use this a lot. It's called Node-RED. It's a drag and drop visual prototyping tool. You can wire together nodes, deploy by clicking that deploy button, and you can really quickly sort of do things that sort of process and respond to events. And it supports a huge range of protocols, including Kafka. So what that would normally mean is you drag on the Kafka nodes, either for consuming events, responding to events, or producing. You double click in and you've got loads of stuff to configure for how you want to connect to your Kafka cluster. But all of this information is, like Nic was just showing, available in that AsyncAPI document. So if you've got an AsyncAPI document that describes your Kafka cluster, you can just provide the location of where that AsyncAPI document is. And you might recognize that it's the same document we've been sort of talking about before, but it's now being understood by Node-RED. And all I can do now is, as it generates the node for me pre-configured. So I can literally wire that to a debug node. And if I go to the debug tab, you can see that the messages have already started to appear. So again, having that machine readable description of your cluster, of your topics, of your data in an open standard that is understood by a wide variety of tools and applications, it's really a helpful way of helping your teams be really productive in getting started with their projects. So, to recap, we started by telling you this story of the kinds of problems that AsyncAPI helps with, of just having that way of discovering what topics are available and having all the information that a developer might need to start writing their application in one place in a predictable format. Nic took you through what that looks like. And on that slide that he had, there was a link to that studio tool he was using. And if you click on that link in our slides, it will take you to that tool and with the document he was showing you. So if you want to go back and have a deeper look into all the different bits that are shown in that example, you can get that there. And then finally, I showed you just a few examples of many. And if you go to asyncapi.com, which is where the community shares a lot of information, you'll find a range of other tools there as well, besides stuff like code generation that we've been sharing. And with that, thank you very much for listening.